using using oxidation numbers to identify redox reactions. So we've got Fe, iron, and sulfur, and they are reacting to give FeS. Now, there are certain rules to determine oxidation numbers, and this is all about electrons. This is the first rule. Each atom in a formula has an oxidation number. That I just showed you, that how in CO2 oxygen is always generally taken to be -2. This is one rule. This is based on electronegativity. These values are based on electronegativity, and so you don't have to remember know why these are the values in O level in class 9th and 10th IGCSE. You just have to know that oxygen has a oxidation number of -2. Then the oxidation number in uncombined element is 0. Now it's quite obvious. If something is uncombined, if something is uncombined, who will it give electrons to? It can't give electrons to anybody. So naturally, its oxidation state is 0. It won't have any charge. You see, if it's not giving or taking electrons from anybody around, it will be 0. All right? Diksha, did you understand? Acha, then this is the next rule, that oxidation number uncombined is 0, and each atom has an oxidation number. The oxidation number is according to the group. So each group, like this is I mean, he says here, this is the uh, way to write oxidation number. The oxidation number of ions is its charge. Naturally, this actually oxidation number is representing the charge. So if this Na gives one electron, it gets positive charge. So it's got a positive one oxidation. And sodium and others have, this is the reason, is positive one. And calcium is group 2, so it will have +2. And aluminium is group 3, it will have, so generally the group number and the valency, because that's the charge it develops after giving electrons. And something is giving, it will be positive. So you can, so this formula, this equation, FeS turns FeS, you don't have oxygen, you don't have hydrogen. So how do you know how to decide what has got redox? How is this a redox reaction? You say Fe was alone, it was 0 here. Inside this, it was a ionic bond. It gave away plus 2 electrons to S. So it developed a charge of +2 or an oxidation number of +2. Sulfur became -2. So this guy went from 0 to +2. It was an increase in oxidation number from 0 to 2, so it got oxidized. That means it, if you look in terms of oxidation number, it comes from 0 to 2. If you look in terms of charge, it from neutral to it become +2. So if it has become +2, it must have donated 2 electrons. It must have donated 2 electrons. And if something donates electrons, it is oxidation. So in terms, you can understand it in a lot of ways. I'm trying to give you the ways. I'm trying to tell you, one, something called electronegativity comes in. Two, the electrons it gives, it develops a charge. Three, the charge is actually a form of oxidation number. And four, if somebody goes from 0 charge to +2 charge, it has an increase in oxidation number. That is called oxidation. It also means it is donating electrons. That is also oxidation. And if the charge is increasing from 0 to positive, that is also oxidation. And sulfur, 0 to -2. So it's convert from 0 to -2. That means it has increased its negative charge. That means it has decreased the oxidation number. It has become 0 to -2. So decrease in oxidation number, and so it is reduction. And also in terms of charge, it has taken 2 electrons. That is why its negative charge has come. So that means it has reduced because it has taken electrons. So by that definition, that oil rig definition, that oxidation is losing electrons, reduction is gaining electrons. The charge and the electron and everything and oxidation number, all these are connected. So in the future, if they ask you to identify what is getting reduced and what is getting oxidized, you can always look at it in 3 4 ways. One, the oxygen addition subtraction. Two, the hydrogen addition subtraction. Three, the oxidation number or oxidation state, and 4, charges and electron transfer. So all these ways you can decide who has got. Some reactions don't have oxygen and hydrogen, so there you have to deal with these two. There's no other way out. And some have oxidation hydrogen, so they are easier to understand, but not all will have. So this is the way. Okay, Diksha, did you understand?